going to do another example, doing some redox stoichiometry. In this case, we're trying to determine how many minutes. So we're actually looking for time in this case. How many minutes does it take to plate 0.925 grams of silver onto the cathode of an electrolytic cell using a current of 1.55 amps? Okay, so in this case, we actually already know how much silver, that being Ag solid, has been plated. Okay, the mass of Ag solid or silver solid equals 0.925 grams. Okay, this is on the cathode, so remember red cat. Red cat tells us that something's being reduced at the cathode, because this is the cathode in this case, so that means the electrons have to come here. I'm going to assume it's a silver ion, but I'm not going to absolutely know until I look at my redox table. But in this case, let's keep noting the things we know. So we know our current to be 1.55 amps. And again, that's in seconds. So we can also notate it as coulombs per second. Okay. And that's about all we know so far. So in this case, if we're going to use our equation, moles of electrons equals it over F, we do know Faraday's constant. Remember, that's in our data booklet. That's on page 3, which I believe is right here. Sorry, my laptop's not very happy with me right now. There's page 3. Faraday's constant, 9.65 times 10 to the 4. So 9.65 times 10 to the 4, and that's coulombs per mole of electron. Okay, so we do have Faraday's constant. So let's kind of note the things we have in this equation. We have Faraday's constant. We have the current. We're trying to find the time. So this is our big question mark here, but we don't have this. Okay, but lucky for us, we can find that. We can find this because we have the mass of silver being plated. We know there's a relationship between the electrons and the amount of silver being plated, and we're going to find that relationship going to our redox table. Okay, so let's find Ag solid. So right there, we have a half reaction. So again, this is at the cathode, so we know there is a reduction half reaction. So we have to read this reaction from left to right. So 1 mole of silver ion adding to 1 mole of electron, creating 1 mole of silver solid. So this is pretty nice, playing out in our favor, because this is all on a 1-to-1 ratio. So let's just write our equation here. So a 1-to-1 ratio works pretty well, because that means the number of moles of electrons equals the number of moles of silver solid being formed. Okay, so let's figure out the amount of silver solid being formed in terms of moles. Then we know our moles of electrons, and then we can use our it over F equation. So let's start by using N of Ag solid equals the mass of Ag solid over molar mass of Ag solid. So in this case, we have 0.925 grams over, and we can find the molar mass by going to our data booklet again. And let's find the page with our molar mass of Ag solid. So just let her load here. Ag solid, silver, silver, silver is found right there. So 107.87 grams per mole. So let's note that down. 107.87 grams per mole. I'm just going to quickly plug in my computer here. Bear with me. Okay, there we go. So 107.87 grams per mole, and that's going to give us the number of moles. So that equals a very small number, 0.00857 moles of silver solid. Okay, now we want to store this value because, again, we don't want to use any rounded values. So store that value as A in your calculator. Now, this equals the number of moles of electrons. Remember, a 1-to-1 ratio is going on here. So this also is our number of moles of electrons. So moles of electrons, which is super helpful because now we have this value. So we can already start using our equation, it over F. We're solving for T in this case. So I'm going to multiply both sides by F. Okay, and then I'm going to divide both sides by current. So divide by current, divide by current. So I'm going to get an equation of time equals Faraday's constant multiplied by the number of moles of electrons divided by the current. So time, remember, Faraday's constant is 9.65 times 10 to the 4 coulombs per moles of electrons, multiplying our stored value, not the rounded value, but I'm going to note it as the rounded value here, 57 moles of electrons, divided by our current, which was 1.55 amps. And your time, remember, this is going to be measured in seconds because this is also 1.55 coulombs per second. Okay, and you are going to get 533.87 seconds. But our original question wanted us to have it in minutes. So I'm going to convert this into minutes. So there are 60 seconds in 1 minute. My seconds cancel out nicely. And in my final answer, I will get 8.90. I'm going to round it to 3 sig digs because my lowest significant digits is 1.55. So 8.9 minutes. So in order to plate 0.925 grams of silver onto this cathode, we need to run our current for 8.9 minutes.